Good morning, all the students. How are you? Yes, all the students. One of the information for you, and our examinations are already postponed. That may you all know very well about that. Because due to the demand of our students and parents about a festival, okay, now our examination postponed up to 18. And one more thing, may you get today one of the good news from the government. Our classes, physical classes may started. We are all made together to go to our schools, and physically we are taking our classes, and you may meet your friends, all friends and teachers. Okay, now be ready for it after Sankranti. Yes, and may possibility to start our further class also after our whatever our further class topic also after our Vasanta Panchami. Yes, so we may initiate it for our further classes. Yes, be ready for your coming 10th class. Yes, now you are in 9th only, but a lot of laws in our 9th class may it will be concluded may for this 18th, after this 18th onwards. You know there is no stop at our online classes. The online classes are going on, but the timing of online classes may changes. Okay, now if there is a government is a permitted at a morning session, we are taking afternoon session. Otherwise, the government is a permitted morning session, we are afternoon session, we take a morning session. But there is no stop of our live classes. Okay, it will be going on. Not a problem for about our live classes. Yes, only 4 classes, no? Live classes. The government may not give a full day schedule for you. If full day schedule is given, also we are continuing the classes. Okay, yeah. Now we are going to our lesson. Whatever we are discussed in the last classes, that is only the what? Refraction of light at plane surfaces. Somewhat remain in that. Just a minute. Yeah, in the last class we already discussed about our multiple choice questions are only remaining. Okay, now yes, if you have any doubts, please ask me in this class. There is about for examination purpose, again we'll get opportunity to discuss that revision concepts also here. Yes, which of the following is Snell law? Which of the following is a Snell law? There is about the multiple choice questions here. There is already we are discussing now. This is this is also we are discussing. So everything is completed in this topic. Yes, and any doubt is there for you? All the students, any doubt is there in this lesson? Yes, so many are asked about our whatever the doubt about our Snella. Once again, I want to go for Snella verification. Yes, once listen carefully now at last, all the students. All the students once listen again about the Snella. Yes, why? Because it is important to derivation. So many are asking the doubt about the Snella in the last classes also. Listen carefully. Yes, what is that Snella and how to derive it? Okay, clear or not all the students? Once take it here. The diagram is a very important. Whatever given, that is a page number. It is a 56. Okay, clear. Now there is a whatever the diagram is a given. Once check it here. There it is a surface of water or a glass. This is taken as the refractive index is a N1. Okay, clear or not all the students? The refractive index is a what for it? It is taken as N1, or otherwise it is taken as our light ray is a moves from where the light ray moves from this particular point, and the refractive index is taken as N2. The velocity of light ray in this particular media is taken as V2. The velocity of light ray in this particular media is taken as V1. You know very well. And now I am taken, there is a what is this? This is only the taken as here our one of the body we are taken here. You know very well. There is a whatever the height of this one, it is taken somewhat A. Okay, and now we have to go. There is a whatever our light ray is come from where? There is a from the point A to here. There is a whatever the light ray is come. It is actually it is taken as a water. You know very well about this Fermat principle. In our 8th class also, you are discussed this type of a thing only. Okay, what is the thing? There is about one tree there. On this particular tree, there is it is a way what we are taken one more tree. There is a one crown. It will be taken here. Okay, clear or not all of you? This crown is taken a grain from here in this particular place too, and again it reaches to here. Okay, like this. There is a whatever the you take like this here. Okay, clear or not all the students? In this format, for the what? For the reflection purpose. Okay, clear or not all the students? In this one, which is the shortest path, means what you have to do? Yeah, there is we have to take one perpendicular line here, and there is the same whatever the position here we taken it is a B, it is a taken A, it is you taken somewhat a point G here. You extended this line here like this. Okay, now in this one is getting as a straight line. The straight line path is only taken as a what actually? That is the shortest path we are taken. Okay, now that is in a reflection purpose. We already discussed it. This is in your 8th class. In this way only same. When there is a light ray is come from here, and one more light ray is taken at here. Okay, clear or not all the students? Got it or not? You take one light ray. What is that? There is a whatever the light rays are coming, and it is reaches to the point B. Here the point B is there here, and taken a different path for this light ray. Okay, here it is taken different path for our light ray. Okay, clear or not all the students? Now there is a path, it is taken somewhat AC, it is written as AC. It is the path we taken, it is as AB path. And the one more path we are also taken here, that is only directly. From where to where? From it is. It is a what? It is an undeviated path. Undeviated path. Okay, clear or not all of you? But it is not occur actually. Undeviated path is possible for our refraction purpose? No. Okay, clear or not all of you? Yes. And now there is a make the light is it is a one normal you have to take here another normal also you take here. Why you take the normal? You know very well, for the finding the refraction position you have to take here. It is a air, it is a water. then automatically our light ray is bending towards the normal only. You know very well about this. Bending towards the normal only. Okay, clear or not all of you? Like these situations are get for us. Okay, got it or not? Yeah, that it is a incident angle, it is a incident angle, it is a refracted angle, it is a refracted angle we are taking here. Okay, clear or not all the students? Yeah, now there is a light ray is traveled from A to the D or A to the C in the air, and from the D to the B and C to the B in the where? In the water. Here, once go to the path ADB, second you go to the path ACB. Okay, clear or not all the students? In the path ADB, okay now, yes, A to D it is in where? A to D it is in A, and D to B it is in a where? D to B it is in a water. Here, A to C in a air and C to B in a water. Only one thing you have to know very well. Our light ray always want to move in which direction? Low time taken path only. Okay, clear or not all of you? When the light ray enter from source and it is traveled in the air, past then the water. You know very well. Past then the water. Okay, clear or not all of you? And now there is a compare here. There is a A to D it is in the air. There is a what? Less distance than the AC. Okay, clear or not all of you? AC is the long distance which is travelled in the air. Okay, clear or not all of you students? Okay, clear or not? And here A to D, from year to year or year to year, the distance is what? Yes, somewhat lesser than the A to C or Y to C. Both are. Okay, but it is in a what actually? It is a long distance travelled in the air, and from year to year then the long distance in the, yes, D to B is a long distance in the water compared with the C to B. Okay, so what you observe from this, the both the paths are may approximately same. Why? Because somewhat time traveled, long distance in the air, less distance in the water. One ray, which ray? ACB ray. Okay, clear or not all of you? ADB ray, there it is a less distance traveled in the air, but long distance traveled in the water. Now, it is both are same. We taken it is both are same. Then you go for our, yes, conclusions. For this purpose, okay, now for this purpose only you have to take here. Yeah, you draw there is a somewhat a perpendicular distances for the finding of the rays for same purpose. You draw one perpendicular distance from where? From C to AD. And one more perpendicular distance line you draw from C to, yes, D to B. Okay, clear or not all of you? That line where points are taken, D is D to AC, whatever line we draw, it will be meted at point E. C to whatever line we draw from D to B, there is a, it will be taken somewhat F. Okay, totally. This portion again we have to draw here. What the portion will be get for us? Yeah, there is, this is only the portion will be get for us. Okay, clear or not? Yes. Now E, it is a point E, and it is a point D here. It is a point C, and the point is it is taken as F here. Okay, clear or not all of you? This is only we are taken, and moreover there is a one more line is also there for here. Okay, got it or not? And taken this whatever the portion may small na and taken like this here. It is a what actually? It is a A. It is a what actually? It is also A only, A to D and A to E. When you extend it here, it will become towards the B. Okay, now it will be like this here. Once check it here, there is a C to B is a lesser than D to B or not? Okay, when you make it is a zoom, C to B is a what? C to B is a AC ray travelled in the water. It is a very less then the dp. These both are same. No, it is not a same here. These both are same. It is not a same here. Okay now. Yes, like that. For that our convenience purpose, we are take here. It is a small distance. A to D is what actually less than E to C. Sorry, A to C, and as well as D to B is greater than C to B. Then the both are taken as same. And here now you take here EC is equal to taken as somewhat V1 into dt del T. Nothing but what you consider from here to here, whatever the distance is traveled, that is may same is equal to here to here also. Okay, clear or not all of you? We conclude that whatever the distance is traveled from E to C is taken as D to F. Okay, clear or not all of you? The time taken for this for the light ray is both for it is the same. That is only del T. The time taken for the light ray here also taken del T, here also taken as del T. But here velocity is taken as V1, the velocity is taken at V2. Already I am written here. Whatever the velocities are there in the water, for the light ray it is a V2. Okay, clear or not all of you? And now it is also written as EC is equal to taken as V1 is equal to written as EC by BC by del T. Okay, clear or not all of you? What is that? Velocity is equal to distance by time. And V2 is equal to also taken as here D2F by del T. D2F by del T. Here it is written as EC is equal to taken as V1 into del T. It is written as df is equal to taken as v2 into del T. Okay, this is taken equation number 1, this is taken equation number 2. Got it or not? Yeah. Now you take here sine theta values. Okay, clear or not all the students? Here let I and R be the angles measured between a path ACB from normal NN perpendicular to short line X here. Okay, clear or not all the students? Here there is a whatever the line we are taken here, it is taken somewhat like this here, angle is taken, it is taken somewhat a normal na. Which one is taken as a normal here? It is a normal here at point C, whatever the line we drawn, it is taken as a normal. Now it is called the incident angle. Clear or not all of you? It is called the refracted angle. Got it or not all the students? In this one only you take a sine angles. Okay, clear or not all of you? Here which triangle? Okay, already I am given this information. The trigonometrical values may get in your 9th class. Sorry, in the 10th class, but only one thing. Okay, there is a what you know. It will be taken as one of the rectangular triangle. In the rectangular triangle, it is in case theta. There is a sine theta is written as. Suppose A, B, C you have to written na. It is written as CB by AC. That is what opposite side by hypotenuse. That is called what actually sine theta. Okay, suppose the cos theta is there, right? It is written as, okay now, yes, that is AB by AC, that is adjacent sine by hypotenuse, that is only written as a cos theta. Tan theta is nothing but opposite by adjacent. Like that, there is a somewhat trigonometrical, yes, ratios are made, you have to go to discuss in your 10th class, but for our, whatever the triangles are there here, what the triangles you have to take here? The triangle is taken here. Which one you know? Yeah, this triangle you have to take here. Which triangle you have to take here? Yeah, there is this triangle in the textbook. It is given somewhat wrong here. That is the sine I is equal to taken as EC by DC, not EC by DF. Okay, now don't confuse here. You take this triangle now. Which triangle? This triangle. Okay, this rectangular triangle you have to take here. There it is a normal for it here. Okay, clear or not all the students? Now there is a what we have taken. There is this is the angle you have to take. This is the I here we consider. What is the triangle? For the sine I purpose. Once again I repeat it here. Listen carefully. Don't confuse whatever the shaded angle is there, the shaded triangle is there, that is only you have to take here. Got it or not all the students? I hope you got it here. There is a whatever the triangle you are take here. Okay, now like that you have to take here. Here there is a E and as well as the C and here you take here EC and here D and as well as the C. Okay, clear? And here you take here, this is only the triangle. Here I is there at D. That's why it is written as what? In the same manner, like a CB by AC, it written as EC by DC. Clear or not all the students? This triangle here it is a I. Okay, now just to rotate it, you got it. And next you take here sin R. Okay, now don't confuse in the textbook. There is it is a given DF. Change it is as a DC, not a DF. It is. Got it? Yeah. Now come to here. What is the sin R? For this purpose, you take this triangle. Yes, this triangle. Okay, clear or not all the students? You take this triangle. Automatically, what will we get for us here? There is it is the same. You take here what the here DC. F DC F here we consider. Now it is written as here you take here it is written as DF by DC. Okay, whatever I consider. Okay, clear or not all the students? Here the same parts here we consider. That is only we taken as what actually sin R is equal to DF by DC. Okay, now you consider from this whatever mathematical formula you applied for these two diagrams. Don't confuse in the textbook because of there is we get you confusion. You write there is a sin I is equal to EC by DC and DF by DC. Okay, now yes, that is only you have to take here. There is a what will we get? Sin I value is there and the sin R values are also there. Once you take the ratios of sin I by sin R, the ratios of sin I by sin R you have to take here. Sin I by okay, now sin R is equal to taken as EC by DC is equal to by DF by DC. Now this one and this one cancel. Okay, clear or not all the students? Now it is taken as sin I by sin R is equal to written as EC by DF. Okay, got it or not? Yeah, already we written here. What is the EC? EC is equal to V1 into del T. Equation 1. DF is equal to V2 into del T. Now sin I by sin R is equal to written as what is the EC here? EC is written as V1 into del T. DF is written as V2 into del T. Now the del T and del T cancel get each other. Now sin I by sin R is equal to taken as yes V1 by V2. Okay, this is only the called Snell law. Okay, now you have already one formula is there for what is the relation between the n and as well as the yes n1 is equal to written as may from the diagram what we written n1 is equal to written as the c by v1, n2 is equal to written as what c by V2. Here which implies V1 is equal to, okay, V1 is equal to taken as what? V1 is equal to taken as C1 by N1. V2 is equal to taken as C by N2. Now this is formula, you take it to the third equation. These two equations are substitute in a third one. Okay, clear or not all the students? The two equations you are substitute in a third one. Automatically what will we get for us? Sin I by sin R is equal to taken as sin I by sin R is equal to taken as what we consider V1 is equal to C by N1. C by N1. Okay, clear or not all of you? And as well as it is also written as C by N2. I hope you got it. There is a refractive index is nothing but what actually? The refractive index are nothing but the ratios between the velocity of light in a vacuum to the velocity of light in a medium. Velocity of light in a vacuum to the velocity of light in a second medium. The first medium we are taken air, the second medium we are taken as a water. In this case you write this velocity of light in a water, velocity of light in a air it is. Okay, at that time you get that information. And here you know very well the refractive index definition. Who knows it is? Automatically you understood. Yes, there is a way to take a ratios of these two things. Okay, clear or not all this? What will we get from that? When C cancel get each other, sin I by sin R is equal to taken as what? N2 is the dose of, and here it is the N1. Okay, clear or not all of it? Is also written as cross multiplication. N1 sin I is equal to N2 sin R. Okay, got it or not? In this way there is the derive our Snell law. Okay, only the part is consideration of there is our sine angles are very important. Okay, consideration of sine angles are very important. Then the remaining just is a mathematical concept only. Here also there is no problem in this one. It is based on a velocity formula. Velocity is equal to distance by time. Okay, now there is a light ray that traveled from E to the C. Where it is? In the air. The air, whatever the velocity of light we have taken, V1. Okay, clear or not all of you? How much time it will be taken for it? Till t time. Then automatically distance by time it is a given the velocity V1. This is a given the velocity V2. It is a D2F is a what? It is a water. That's why the velocity of light ray in a water it will be taken as V2. And we consider the time is the time taken for the D2C travel whatever the light ray is the taken time E2C. That's why it is also written as dF is equal to V2 into del T. There is no problem about this, I hope. Problem is about this one only. That's why you write like this. You take a normal and you write that angles. You know very well this is the R, automatically it is also become R. From this one there is it is become I. From the triangles already I am drawn here like this CED. And another triangle there is a what? D, C and another the F. This triangle only you have to take here. What is there here? Here R is there. At where? At C R is there. At where it is I it will be there. It is a I automatically. Okay, at the D what will be there? I. From this one sin I and sin R will be get for us. And then after you take the ratios of the sin I and sin R values, then you get this. Okay, clear or not all of you? You know very well from the equation 1 EC is equal to V1 into del T. dF is equal to V2 into del T. Substitute it, automatically you get this formula. And from this formula already you know very well what the refractive index is. From that one refractive indices are substituting that, you will get the sin I by sin R is equal to N2 by N1. This is only about Snell law. I hope all the students you got it about this Snell law. Okay, now once again you go through the Snell law. Only one thing in our textbook there is a sin I. Okay, now the ratio of sin I may given wrong. Okay, clear or not all the students? Once check through that. Okay, yes. We concentrate on it. Who know the fundamentals, automatically you'll get it is now. Yeah, any more doubts are there in this lesson? In the textbook somewhat wrong is a given. Okay, you correct it at a sin I. the page number, that is only sin A is equal to EC by DF they are given. EC by DF it is not, actually EC by, it is DC, EC by DC, as easily understood now, you, for you. Yeah, about the mirages, okay. Now already so many times we have discussed once here. Yeah, statement is the ratios between incident angle sine of, the ratios between sine of incident angle to the refracted angle is equal to relative refractive index of the mediums of refraction are ratios of velocities in the light rays in the medium. Okay, clear or not all of you? The ratios of incidence and refracted of sine angles, refracted sine angles is equal to ratios of refractive indices, that is only called relative refractive index, are ratios of velocity of light rays in the mediums. This is only we are taken as what actually, this is only taken as a, yes, our without the velocities it is not possible to find out our refractive indices. Okay, clear or not all of you? Without the velocities it is not possible to find out the refractive indices, and otherwise you apply the Snell law. At that time only it is a possible. By using the Snell law it is a possible easily when you know the sin I, okay, now, and the sin R, at that time you will get the what? N2 by N1. By using this formula you will get that. Okay, sin I by sin R is equal to N2 by N1. Na? In case you know the I value, in case you know the R value, automatically whatever these ratios are there, that ratios may equal to the ratios of refractive index. From that one may have possibilities. Okay, clear? Without V also it is made possible here. Yeah. Mirages are nothing but simply only one thing. Mirages are formed due to the total internal reflection. Yes. How to find out V in N is equal to CV? That is only, you know very well, the velocity of light in air is, suppose you take a water here. Okay, from here to here there is a light velocity, it is the air, it is the water. Okay, clear or not all the students? Yes, there is a air, in the air the water will travel the 3 into 10 to the power of 8 meter per second. Okay, clear? But when it is enter into this, automatically you not get that 3 into 10 to the power of 8 meter per second. Its velocity decreases. Okay, in case you know that whatever the distance you are taken for the traveling of light, automatically you get the velocity. There is no doubt. Velocity is equal to what? Distance by time. Distance by time. In case you know the distance, this distance. Okay, clear? Yes, this distance and time taken from here to here traveling, you will get the velocity of that particular light in a medium also. Okay, clear or not all the students? Suppose you take it is a fractions of second you have to take. That is a difficulty to a normal situation. Okay, now otherwise you require 3 lakhs kilometer per second. Why? Because in case you take it is in a water also, mainly you maintain 2 into 10 to the power of 8 meter per second. 2 lakhs kilometer per second. You want to observe this thing. That's why there is a fractions of second only that small distances may travel by the light. That's why only we used these formulas. Light refraction or reflection formulas we are used. Okay, but that is easily may understood. Already in our class also we are done that experiment. Okay, in case it is a passes through the glass, in case it is a passes through the water, how much refracted for a incidence angle. So automatically you get the sin A by sin R values. Okay, that will be give the velocity of light also, and the refractive index of the medium also, and all the values may get from this Snell law. Okay, got it? It may somewhat difficult. Why? Because large distances are required and it may be observed in a small time only. Okay, yeah. I hope you got it. And mirages are it is one of the optical illumination of a total internal reflection, which is a form of due to the total internal reflection. Only one thing keep in your mind for the mirages. You want to prepare the mirages, it is easily possible to you also. Okay, clear? Yes. And only one thing, you heated that. You take a light enter from where? Denser medium to the denser medium only again. Okay, now denser medium to the denser medium only. Simple thing. There is a road. It is, and above that air is there. Yes. And especially at the summer session, there is a very hot situation is there. That's why here sun is provide the heat for this air. This air is heated. You know very well in your which class? In the 7th class only you already discussed it. What is that? Air, wind, cyclone lesson. When the air is heated, automatically it will become what? It will be moves in upward direction. Okay, clear or not all of you? It will be moves towards the cold direction. The density of heated air is decreases. Then the density at a higher level from this. Okay, above this, whatever the air is there, the density of this air at this particular position is greater compared with this position. Okay, now it is a denser than this. Okay, when the light ray is enter from this portion, okay, now it is a what actually? It is a denser air. It is a contains actually. Okay, denser air it is a contains. When the light ray comes from here, it is not reaches to this particular place. Why? Because in case this incident ray may critical angle with incidence with the critical angle at this particular surface. Which surface? Where there is a rarer density air and here higher density air. Here it is a contained what in this particular place nearby the road, rarer density air. Here at the above that it is contain the what? Higher density air. Now our light rays are coming from where? High density air to rarer density air. So in case once again the condition is what? Our incident light rays which is coming from the sun. It is a fall at where? On the surface of separation of the rarer air to the denser air. Automatically it is returned back when it is less than the critical angle. Clear or not all of you? When our light ray is incident less than the critical angle, automatically it is returned back into original plane only. Okay, clear or not all the students? Why? Because our refracted ray is makes angle with this normal. Wherever you draw the normal at here. Okay, clear or not all the students? It is more than the 90 degrees, not equal to 90 degrees. It is greater than the 90 degrees. Again, it is enter into this one only. What is there here? Here, may the sky will be there in this particular position of separation. What will be there? May sky will be there. The sky image is only appear at this particular place. Why? Because you know very well in the reflection phenomena that what will appear here, whatever the ray will be taken, the object image that will be only appear on the surface. Now here it is a works on the surface. That's why the light rays enter like this. Whatever the image is there, the sky image is may appear for us. Okay, clear or not all the students? I hope you got it. Just only one thing, because of the heating the air, that become the denser. The light ray enter from denser medium and it is ready to come into denser rarer medium, but no possibility to enter into the rarer medium. Because of total internal reflection, again it is comes to its original plane only. Got it or not? Yeah. This is only about the total internal reflection phenomena. I hope you got it, all the students. Thank you. Bye. Take care. And tomorrow we'll go with the one more revision of all these 4 lessons. Okay, now don't miss it. Tomorrow I want to go with the revision of these all 4 lessons. Bye. Take care. Yeah, don't confuse about Snell law. Once again I repeat it here already today. Once check it today's class. Okay, clear? Yes. Here there is about somewhat mathematical formulations are all there. Simple formulations are only there. Okay, now you be concentrate on the refractive index definition first. Then you concentrate on the sin theta. May you confuse it get because of the textbook is given somewhat wrong about a sin angle. Okay, now there is a sin angle nothing but opposite side to the hypotenuse. That is a given somewhat wrong. Don't confuse about that. That once correct it, you will get it. Okay. Bye. Take care, students.